Friends, in last class already we are finding about parallel plate capacitors capacitance. Okay, if suppose in between the parallel plates in a capacitor air medium is present, means that one having capacitance C value is equal to epsilon naught A by D. If suppose in between the plates we are introduced a dielectric slab or dielectric material having dielectric constant K, means in that condition C medium value is equal to K into epsilon naught A by D. Like that already in last class we are discussed. Today in this class we want to discuss about series combinations and in parallel combinations. So first of all, how we are representing here series combination and parallel combination is, for example, now I am representing here series combination, one rough diagram. So in this series combination, just I am taking few capacitors like this. For example, this is capacitor 1 and this is capacitor 2 and this one is capacitor 3 and this one is capacitor 4. For example, this is one terminal and this is another terminal. For example, maybe this is X one thing and this one is Y one thing. This is first capacitor having capacitance C1, here second one having C2 and third one having C3 and fourth one is having C4. Let this is a positive terminal, this is negative terminal and this is a positive terminal, this is negative. Like that I am representing here positive and negative terminals. For example, see friends, this is first capacitor. In this first capacitor we are observing this is second plate. This second plate is connected to first plate of second capacitor and this is the second plate in second capacitor that is connected to first plate in third capacitor. Okay, and then in third capacitor second plate is connected to fourth capacitor's first plate. Like that we are substituting or we are introducing like this type of combination we are calling as what's the thing here, series combination. See, in series combination, one plus and negatives we are connected here negative positive and here negative positive. And also we are observing this is the first capacitor and this one is the here last capacitor. First capacitor first plate is connected to positive one and last capacitor last one plate is second plate is connected to negative one. So here first plate in first capacitor and second plate in last capacitors are connected to different opposite terminals. So okay, this type of combination only we are calling as series combination. So further we want to go for parallel combination. See how we are representing this parallel combination means, for example, here also I am taking a few capacitors like this. For example, this is one capacitor, this is another capacitor, this is another capacitor and here also another capacitor. All these capacitors are present like this. Let this is a C1 and this one is C2 capacitance and here this one having capacitance C3 and this one is having capacitance C4. For example, we are giving here terminals like this. This is maybe I am taking as A and this one I am taking as B. Let this one is positive side and this one is negative. So here this first capacitor, this plate is having some positive charge and here also positive, here also positive and here also positive. Here another plates we are considered all are having this is negative, this is negative and this is negative and this one is also negative. So here we are observing all the positive terminals are connected together and all the negative terminals are connected together. This type of combination only we are calling as parallel combination. So now we are ready to discussing about effective capacitance in both the combinations. First we will go for series combination. Okay friends, now we are going for expression for equivalent capacitance in series combination of capacitors. So just now only we are informed. So what we are informed, in series combination the capacitors are arranged as second plate of first capacitors is connected to the first plate of the second capacitor. The second plate of the second capacitor is connected to the first plate of the third capacitor and so on. And finally the first plate of the first capacitor and the second plate of the last capacitors are connected to opposite terminals of the battery. So the same thing we are introduced here. For example, I am taking here three capacitors having capacitance. One is C1 and another one is C2 and another one is C3. Okay, this is actually first plate and this is second plate. Here this is first plate and this one is second plate and this one is first plate and this one is second plate. Here first capacitor first plate is present here. Here first capacitor second plate. Here first capacitor second plate is connected to first plate in second capacitor. So further second plate in a second capacitor is connected to first plate in third capacitor and so on. So this type of combination only we are calling here as what's the thing here, series combination. So for example here these three capacitors connected in series. Along with that we are introducing one battery having potential V. Here when battery we are introduced, this is the positive terminal of the battery and this one is negative terminal of the battery. For this thing we are introducing one equivalent circuit like this. Here equivalent circuit is we are represented like this. Here this is a CS we are represented. Here CS is nothing but effective capacitance in series combination. Here battery is present. When introducing a battery in this circuit, compulsory the charges will be flows in that. The charge flowing in the circuit is we are taken as Q. How much charge we are taken here? Charge Q is we are taken here. So friends, very important point I am representing here. If suppose a charge Q is present, means that same charge is passes through C1 and then it will be passes through C2 and then it will passes through C3. So here there is no chance to divide that charge in that circuit. Means in series combination charges flows is we are taken as constant, but here we are given potential in a circuit is divided into individual potentials through here capacitor C1. Here potential is V1 is developed in C2 capacitor. V2 is we are observed potential, and in C3 capacitor potential is V3. So total potential in this circuit we are taken as V is equal to V1 plus V2 plus V3 developed in 3 capacitors. Let that only I am taken as equation 1. Here equation 1 is V is equal to V1 plus V2 plus V3. So friends, now we know the already capacitance concept. By the concept of capacitance we have one fundamental relation, C is equal to Q by V. So further we are notation that one as V is equal to Q by C. Here V1 developed in first capacitor and V2 developed in second capacitor and V3 developed in third capacitor, and V is entire circuit we are taking. So here we are observing as V1 is equal to Q divided by C1, since here Q is constant. Similarly V2 is equal to Q divided by C2 and V3 is equal to Q divided by C3, and V is equal to we are represented as Q divided by CS. So here friends, by equation 1 already we have V is equal to V1 plus V2 plus V3. By known values for V, V1, V2 and V3 we are substituting like this as Q divided by CS is equal to Q divided by C1 plus Q divided by C2 plus Q divided by C3. Here Q divided by CS is equal to, we are taking here Q common, therefore Q times of 1 by C1 plus 1 by C2 plus 1 by C3 we will get on both the sides. Further we are cancelling that charge Q, so we are getting like this as 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Here CS is effective capacitance in series combination. Okay, how we are ready to defining in a series combination means the reciprocal of effective capacitance in series is equal to sum of reciprocals of individual capacitance. For example 1 by C1 is reciprocal for first capacitance and 1 by C2 is effective capacitance for second capacitor, like that. So finally we are obtained like this, 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Like this we can able to find out effective capacitance in series combination. If suppose we are taken n capacitors in a circuit means, okay, each capacitor's capacitance like this we are represented C1, C2, C3, C4, like that. How many we are taken? Totally we are taken as n capacitors. So here we are observing the notation like this as 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus so on 1 by Cn. Okay friends, now only I am taking two capacitors having capacitance C1 and C2, those two are connected in series combination. Which combination we are taking? In series combination we are taking. So in that condition, effective capacitance we want to calculate. So here we are getting 1 by Cs is equal to 1 by C1 plus 1 by C2, and then here 1 by Cs as is we are representing, here C1 C2 is LCM. So by taking a C1 C2 LCM, numerator we are represented as C2 plus C1. So by taking reciprocals here, finally we are getting Cs value is equal to C1 C2 divided by C1 plus C2. See here, Cs is equal to how much observed for only two capacitors? C1 C2 divided by C1 plus C2. Here one example we are giving. So for example, this is one circuit. In that circuit, two capacitors I am taken. For first capacitor, that capacitance value is 3 farad, and second capacitor having a 6 farads value. So here we have formula Cs is equal to C1 C2 divided by C1 plus C2. Instead of C1 I am represented 3, instead of C2 we are taken as 6 whole divided by 3 plus 6. So here 3 into 6 is equal to 18, 18 divided by 3 plus 6 is equal to 9, 18 by 9 is equal to 2 farads. That is the effective capacitance value when 3 farads and 6 farads are connected in series combination. Okay friends, one more case we are ready to discussing. If suppose we are taking n identical capacitors, we are taken, all those capacitors are connected in series combination. For example, each capacitance value we are taken as a C. So let here C1 value is equal to C2 value is equal to C3 value is equal to C4 value is equal to Cn. All these values I am taken as a C. So that this one is I am taken as C, say. So we have fundamental formula. What is the fundamental formula here? 1 by Cs value is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4 plus so on 1 by Cn, like that. So all are identical values. So therefore here 1 by Cs value is equal to 1 by C plus, then 1 by C plus, 1 by C plus, 1 by C plus, so on 1 by C. How many times we are taken here? N times we are taken. Why reason is here how many capacitors is we are connected in series combination? N identical capacitors we are taken in series combination. Therefore 1 by Cs is equal to, here by taking the LCM C, then we are getting like this in numerator as 1 plus 1 plus 1 plus so on 1. How many times? N times. So therefore 1 by Cs value is equal to N by C we are getting, and Cs value is equal to C by N we are getting. So here we are observing one small example also friends. Here in between the two points A and B we want to find out effective capacitance. Here how many capacitors are present? 4 capacitors. See, this is 1, this is 2nd, this one is 3rd, and this one is 4th. All these capacitors are having the same capacitance, that is nothing but 8 farad. So here capacitance value is equal to 8 farad, and number of capacitors were taken as 4. Then Cs value is equal to, we have one fundamental formula C by N. Here C value is 8, so therefore here we are taken as 8, and N value is 4. Here we are taken as 4. On a calculation, effective capacitance we are obtained as Cs is equal to 2 farads. Okay friends, before starting the class already we are discussed about parallel combination also. In parallel combination what we are informed, number of capacitors are connected between 2 points across the same potential difference. Such arrangement is called parallel combinations of capacitors. And also we are informed all the positive terminals in a capacitors are connected together, and also all the negative terminals are connected together. So the type of combination only we are calling as a parallel combinations of capacitors. Now we want to find out effective capacitance in case of parallel combination. That effective capacitance in parallel combination is we are represented as Cp. Okay friends, now I am taking 3 capacitors, each having capacitance C1, C2 and C3 like that respectively. All these capacitors are connected in parallel combination, and also we are introduced a battery having potential V in that circuit. So just we are observing here one circuit diagram. So here observe the thing, this is C1 and this is C2 and this is C3. These 3 are in which combination here? Parallel combination. For those things, which one is we are introduced here? One battery having potential V is introduced. So further, this one equivalent circuit is represented like this. This is equivalent circuit. Okay, in this equivalent circuit, effective capacitance I am taken as a Cp. Here battery having potential V. So friends, in first diagram observe carefully. Up to here charges Q is present. Here for charge, how many roots we are observing? 3 roots is observing. So along this capacitor C1, how much charge is flowing? Q1 charge is flowing, and along through capacitor C2 charge Q2 is flowing, and through similarly C3 Q3 charge is flowing. So from this diagram we are concluding here, in parallel combination charge is divided. So charge is divided means in parallel combination which one is remains constant? Electric potential is remains constant. Here charge is divided means that total charge how we are represented means here Q is equal to Q1 plus Q2 plus Q3, like this we will represent. This is charge or net charge present in the circuit. So further we know the concept of capacitance. From the concept of capacitance we have C is equal to Q by V, and then Q is equal to CV. Here just we are identifying few relations. Those are, here Q1 value is equal to C1V. Since reason is here V is constant. Similarly Q2 is equal to C2V, and also Q3 is equal to C3V, and finally Q is equal to CPV. Here CP is nothing but what? Effective capacitance in parallel combination. So from equation 1 we have the notation Q is equal to Q1 plus Q2 plus Q3 like that. So here CPV is equal to C1V plus C2V plus C3V like that, and CPV is equal to, here by taking the potential V common, this one we are able to write like this: C1 plus C2 plus C3 into V. Here V and V will be cancelled each other, therefore Cp value is equal to C1 plus C2 plus C3. So where Cp is what we are calling here effective capacitance in parallel combination. So in parallel combination we may able to understand effective capacitance is equal to sum of individual capacitance only. Effective capacitance is equal to how much? Sum of individual capacitance only. That only effective capacitance in parallel combination. Okay friends, now we will discuss about a few cases also. First case I am representing here. If n capacitors are in parallel combination, then how we will get each capacitor like this we are taken means C1 comma C2 comma C3 comma C4 comma so on Cn means effective capacitance value in parallel combination is Cp value is equal to, we can able to write as C1 plus C2 plus C3 plus C4 plus C5 plus so on Cn. So what I am represented here, Cp value is equal to, for n capacitors, C1 plus C2 plus C3 plus C4 plus C5 plus so on Cn. Okay friends, we have one more notation here. For n identical capacitors we are taken, all those are connected in parallel combination. Means what's the thing here? C1 value is equivalent to C2 and also equivalent to C3 and also equal to C4. Means C1 is equal to C2 is equal to C3 is equal to C4 is equal to so on Cn is equal to C. Just we are imagine means. Here Cp is equal to, we have already one formula, Cp is equal to C1 plus C2 plus C3 plus C4 plus so on Cn. All these values are identical. So Cp is equal to C plus C plus C plus C plus so on C. Here how many capacitors we are taken? N capacitors we are taken. So here how many times we are taken here? N times. So therefore finally Cp is equal to, we are able to find as N into C. Few examples we will discuss now. For example, example 1 answer we will check it. So in example 1 I am taking different types of capacitors having capacitance value. One is 2 farad, 3 farad, 4 farad and 5 farad. Here 2, 3, 4 and 5 farads all are in which combination? Parallel combination. So what is the effective capacitance in between the two terminals X and Y means Cp is equal to, we have formula C1 plus C2 plus C3 plus C4. Here 2 plus 3 plus 4 plus 5. Finally we will get here how much? 14 is the answer, or 14 farads is the answer here. So in second example, once observe carefully friends, here 2 farads is taken, here also 2 farads is taken, here also 2 farads is taken. Let this is one terminal A and this is another terminal B like this. In between A and B we want to find out effective capacitance. Here all are identical capacitors. So here C value is equal to, we have 2 farads, and how many capacitors is present? 3 capacitors. So n value is equal to 3. So therefore we have one fundamental thing, Cp is equal to n into C. So Cp value is equal to 3 into 2, then Cp value is equal to 6 farads were identified. Okay friends, one more case we will discuss here. When unidentical capacitors are present, means if suppose those unidentical capacitors initially were connected in series combination and then in parallel combination. So in series combination means we can get like this as C by N, and in CP means in parallel combination means CP is equal to N into C. By taking the ratio for Cp by Cs, we may get how much? N square like this. So what is the ratio when identical N capacitors in series and in parallel combinations connected? Means Cp by Cs value is equal to N square, like that one notation we may observe. Okay friends, in next class a few more applications we will discuss about series combinations and parallel combinations. Thank you.